Carbon-14 was used to determine the age of the Dead Sea Scrolls. If the Dead Sea Scrolls were determined to be 2,000 years old and the half-life of carbon-14 is 5,730 years, what fraction of this half-life has passed? So one of the important parts, is that the half-life of carbon-14 is 5,730 years. So what they're telling us there is that one half-life is equal to 5,730 years. We would like to know how many half-lives 2,000 years is. So we're doing a conversion problem. We're converting years into half-lives, and we're going to use this equality to do it. So we're going to start with our 2,000 years. So we want to use this equality to write a conversion statement that will convert years into half-lives. I'd like years to disappear, so I'm going to put the 5,730 years on the bottom, and I'm going to put the one half-life on the top. So it's a division problem. We're going to take 2,000 years, multiply by 1, and divide by 5,730. Our answer will be 0.3490, and years canceled, so we're left with half-lives. Now, I really can't record this many numbers. It looks to me like up here I only have one significant figure, so I better change this to 0.3 before I write my final number. So it's 0.3 half-lives. We only want to record one significant digit, because that's all we started with. Right, so let's do one that's a little more complicated. The half-life of iodine-123 is 13 hours. How much of a 64 milligram sample of I-123 is left after 26 hours? So we've got the same sort of setup here. The half-life of I-123 is 13 hours. So one half-life is equal to 13 hours. They wanted to know how many half-lives, how much is left. So we'll need to know how many half-lives have passed. So let's start with our number of hours and convert our hours into half-lives. So 26 hours we want hours to disappear, so let's put our 13 hours in the bottom and our one half-life in the top. If I take 26, multiply by 1, and divide by 13, I'll get 2 half-lives. So in the 26 hours, 2 half-lives passed. We started with 64 milligrams. In one half-life, half of our 64 milligrams will be gone. So that will be 32 milligrams will be left. That's one half-life. But we had 2 half-lives pass, so we'll have to half this again and get 16 milligrams. And that's our answer. We have 16 milligrams of our 64 milligram sample left. Okay, the third one I want to do, and I'll put the paper so we don't get so much. The radioisotope strontium-90 has a half-life of 38.1 years. If the sample contains 36 milligrams of strontium-90, how many milligrams will remain after 152.4 years? So this will set up the same way. The strontium-90 has a half-life of 38.1 years. So we'll say that 1 half-life is equal to 38.1 years. We'll need to convert our number of years into half-lives. So we have 152.4 years. We're taking this equality and converting years into half-lives. We're going to divide by 38.1 years so that years will cancel. Put 1 half-life up here in the top. Years cancels. 152.4 times 1 divided by 38.1 will give us 4 half-lives. In this class, although not in life, these will always turn out to be even numbers. You won't have a 4.5 or anything else. It'll be even. Or not even, it's whole. It'll be a whole number. Okay, so we start with, let's see, in the problem we're starting with 36 milligrams. So we've got 36 milligrams of our strontium. The first half-life cuts it down to 18 milligrams. 18 is half of 36. Second half-life cuts it down to 9 milligrams. 9 is half of 18. The third half-life cuts it down to 4.5 milligrams. And the fourth half-life, I'm not off the paper yet, cuts it down to 2.25 milligrams. And when we report this number, we're going to need to round it because we've got too many significant figures here. We only need 2 significant figures. So it'll be 2.3 milligrams is what we'll report. And that's it.